Satellite of mass m is launched from the surface of a planet of mass m and radius r at an altitude of 2r into a circular orbit. What is the minimum energy required to launch the satellite is? To calculate the minimum energy required to launch a satellite of mass m from the surface of a planet of mass m and radius r into a circular orbit at an altitude of 2r, we follow these steps. Step 1. Gravitational potential energy on the surface. The gravitational potential energy, U, of the satellite when it is on the surface of the planet is, U1 is equal to minus capital G into capital M into small m divided by capital R, where G is the gravitational constant. Step 2. Gravitational potential energy at the altitude h is equal to 2r. The altitude of the orbit is h is equal to 2r, so the total distance from the planet's center to the satellite in orbit is r plus h is equal to 3r. The gravitational potential energy, U, of the satellite in orbit is, U2 is equal to minus capital G into capital M into small m divided by 3r. Step 3. Kinetic energy in the orbit. To maintain a circular orbit at altitude 2r, the satellite requires a certain orbital speed. The orbital velocity v is given by v is equal to square root of g m by r, where r is equal to 3r is the radius of the orbit. Therefore, v is equal to square root of g m by 3r. The kinetic energy, k, of the satellite in orbit is, k is equal to half m v square. After substituting the value of v, k is equal to g, small m, capital M, divided by 6r. Step 4. Total mechanical energy in orbit. The total mechanical energy of the satellite in orbit is the sum of its kinetic and potential energy, E orbit, is equal to U plus k. Therefore, E orbit is equal to minus capital G into capital M into small m divided by 6r. Step 5. Energy required to move from surface to orbit. The energy required, delta E, is the difference between the total energy at the orbit and the energy at the surface. Delta E is equal to E orbit minus U1. After substituting the values of E orbit and U1, we get delta E is equal to 5 capital G into capital M into small m divided by 6r. Final answer. The minimum energy required to launch the satellite into a circular orbit at an